So now we're going to be looking at some other rules, namely product rule and quotient rule in some of these problems here. So for the first couple, it says, in these following problems, use the product rule to differentiate the product and manipulate the function algebraically and use the power rule to compute the derivative and then compare the two. So first I'm going to do product rule for these. So product rule would say I take the first times the derivative of the second. So I would say x times the derivative of this one, which is 2x plus 3, plus the derivative of x, which is 1, times this function unchanged. It doesn't really matter which order you do it in because you're adding. And so I would get, if I were to expand this out, I would, distributing the x, I would get 2x squared plus 3x plus this x squared plus 3x. And so I would end up with these x squareds and these x's will combine to be 3x squared plus 6x. Okay. I could also distribute this and then start with x cubed plus 3x squared. So this is part B. And then I simply use the power rule here. In this case, I would get 3x squared plus 3 times 2x, which would be 6x. So that'd be 3x squared plus 6x. And these two are the same. Okay. So that's all the problem's asking you to do. So let's do product rule for this. I'm going to do this one, 2s minus 1 times the derivative of this. The derivative of s is just 1, and the derivative of 4 is 0. So I just have 1, plus the derivative of that, which is 2 times s plus 4. And if I were to distribute everything, this would be 2s minus 1 plus 2s plus 8. The s's combine to become 4s. Negative 1 plus 8 is minus 7. And for part B, to distribute first and then do it, I would say, well, I'd have to FOIL this out. That would be 2s squared plus 8s minus s minus 4. Or that would be 2s squared minus plus 7s minus 4. And then doing the derivative of this, using power rule, that would be 4s plus 7. Oh, why did I get plus there? So this should have been plus 8. Oh, this should have been plus 7. I don't know why I messed up there. That should have been plus 7 also. Negative 1 plus 8 is plus 7. Okay. So now we're just going to apply product rule to a lot of these. So it's just sort of mechanical when you're doing these kinds of things. I'm going to do, you can do, the way I think of it is I'm doing one times the derivative of the other, and then I swap. And then I add them together. So I'm going to do x times the derivative of sine. Derivative of sine is cosine. Plus now this term gets a term being the derivative. That's 1 times sine x. So it's just x cosine x plus sine x. Okay. Now we're going to look at some quotient rule problems. So this is use the quotient rule to differentiate the product. And then we'll do it two ways. One with quotient rule with A, and then part B with some algebra. So quotient rule is I do the bottom. This is the process I do, is the bottom times the derivative of the top, which is 2x, minus the top, x squared plus 3, times the derivative of the bottom, times 1, divided by the bottom squared. That's how I remember it mechanically. I'm going to do bottom, derivative of the top, minus top, derivative of the bottom, divided by the bottom squared. There's some mnemonics that you can use to memorize that, but that's 2x squared, and then distributing the negative sign is minus x squared minus 3 over x squared. And that would be x squared minus 3 over x squared. And you could leave it like that, or you could rearrange, but I'll just leave it like that for now. I can also divide these x, right? And so x squared over x, like I can make this x squared over x plus 3 over x, which is really x plus 3x to the negative 1. And then I can do power rule. The derivative of x is just is 1 plus 3 times negative 1 x to the negative 2 by doing power rule. So I'd bring the negative 1 and then subtract 1. And this is 1 minus 3 over x squared. And this one I can simplify because I can divide the x squared. This is equal to x squared over x squared minus 3 over x squared. That's equal to 1 minus 3 over x squared. So you see these two are the same. Same with this one, we're going to do quotient rule. Do the bottom times the derivative of the top. The derivative of 3 is just 0 because it's a constant, minus the top times the derivative of the bottom, which is 12s squared, because I bring the 3 down, so 4 times 3 is 12, and then subtract 1, divided by the bottom squared. So this part is 0, so this is just minus 36s squared over, and when I square both of these, so it's 16s to the 6th. And that I could simplify by dividing by, what, 4? So that's 9 and a 4. Minus 9 over 4, and this just becomes s to the 4th, 1 over s to the 4th. Okay? Or I could just do power rule here. So h of s I can rearrange. I can bring the 3/4 out in front, and the 1 over s cubed would be s to the negative 3. And then using power rule, I would find, I would multiply by negative 3. So 3/4 times negative 3s to the negative 4. Negative 3 times 3/4 is negative 9/4. And then I get s to the negative 4, which is 1 over s to the 4th. You see? That matches that one there. Okay. So now we're going to use the quotient rule to just differentiate a bunch of products. Bottom times the derivative of the top, which is just 1, minus top times the derivative of the bottom, which is 1, divided by the bottom squared. This is x plus 5 minus x minus 7. So the x's are going to cancel, divided by x minus 5 squared. And so that ends up being 5 minus 7 is negative 2 over x minus 5 squared. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.